Actions after receiving network packets. After receiving a network packet, the base platform has the following options to act on this packet: accept, drop, reject, DNAT, and redirect. The attributes associated with each rule operating on the IP traffic shall have: where the packets come from, source, where the packets should go, destination, whether the protocol is TCP or UDP, destination port, source port, and original destination IP address. The actions are performed according to some of those attributes by the base platform. We roughly introduce those actions here, and the usage of those actions will be shown in the following sections. The action accept is to accept the network traffic matched all the attributes of the rule. For example, to allow all the telnet connections, TCP port 23, from zone net to the base platform FW, the action accept can be used by specifying source, net destination, FW protocol, TCP destination port 23. The action drop is simply ignoring the arriving packets of the specified attributes. The difference between drop and reject is that reject would send some messages back to the sender that the connection is not reachable in some cases. Please note that we have those predefined rules between zones by default. Thus, we only need to specify drop and reject if necessary. For example, traffic originated from zone LOC to zone net is allowed by default. If we would like to block all the HTTP access from LOC to net, then we can do drop by specifying source, LOC destination, net protocol, TCP destination port 80. The action redirect is to redirect the traffic arriving at the base platform to another port of the base platform. We usually do this by trying not to reconfigure the application daemon, but we would like to have that daemon ISIN on more port. For example, telnet traffic is usually using TCP port 23. But we would like to have TCP port 28 also handled by the telnet daemon. In this case, we can use redirect. And as we mentioned earlier, the action DNAT is to do port forwarding by changing the destination IP address of the arrival packets from zone net to a host in zone DMZ or zone LOC. This host does not need to have a physical entity, it can be a virtual host as long as it can handle the forwarded traffic. Add rule. Adding exception rules can be done via border rule. Add rule. Illustration 41, screen snapshot for adding rule. Before adding a rule, please make sure where your host, no matter if it is virtual host or host with physical entity, is situated. If it is a virtual host, you need to make sure it has a network interface joining that bridge. For a host with physical entity, check if it is properly connected. For hosts situated in zone DMZ, using DHCP to get IP address from base platform is not working. The reason is that we have predefined rule to block access from zone DMZ to zone FW. Thus, DHCP packets will be rejected by the base platform. You have to set IP address manually for the hosts in zone DMZ. Illustration 42, source and destination associated with rule. Those predefined rules will not be displayed, but you should be familiar with them while adding exception rules. It is of no use to add new rule by allowing connections from zone LOC to DMZ because the base platform already admitted the rule by default. However, it makes sense to add exception rules by allowing connections from zone DMZ to zone LOC because the connections are blocked by default. Similarly, it makes sense to add exceptions from zone net to zone FW because the connections are blocked by default as well. For example, source, net destination, FW protocol, TCP destination port 23. And press add button. The rule will be in effect after restarting the border control engine. It allows telnet connections, TCP port 23, from zone net to zone FW. In the following sections, we are going to provide some examples for reference. Allowing exceptions for TCP connections from DMZ to LOC. The connections from zone DMZ to zone LOC are blocked by default. However, we would like to add rule for allowing TCP connections from DMZ to a host with IP address 172.16.9.12 in zone LOC. Illustration 43, adding exception rule from zone DMZ to LOC. Please check the following screen snapshot while specifying specific IP address 172.16.9.12 of a host in zone LOC. Illustration 44, screen snapshot for DMZ to a host in LOC. To specify a specific host, it is necessary to use the following format in the box next to specify: zone IP _ address or zone subnet. For example, LOC 172.16.9.12 or LOC 172.16.12.0/24. After pressing add button, the associated rule can be viewed via border rule list/remove rule. Illustration 45, display the rule from DMZ to a host in LOC. Reject or drop connections. The connections from zone net to zone LOC are forbidden by default. Thus, it is not necessary to add redundant rules by reject or drop connections from net to LOC. It is the similar case for the connections from zone DMZ to LOC. The connections from zone LOC to zone net are allowed by default. If we want to add exception rule to block HTTP traffic from LOC to net, we can do source, LOC destination, net protocol, TCP destination port, 80 source, LOC destination, net protocol, TCP destination port, 443 HTTP and HTTPS are using TCP port 80 and TCP port 443. Just enter them as follows by pressing Add button. The rules will take effect after restarting the border engine. Illustration 46, screen snapshot for dropping HTTP traffic from LOC to net. Illustration 47, screen snapshot form dropping HTTPS traffic from LOC to net. Illustration 48, example for dropping HTTP and HTTPS, ports 80 and 443. Redirect traffic to another port of the base platform to redirect the network traffic from one TCP/UDP port to another. It usually involves some network environment issues or legacy systems. For example, you are under the environment of blocking telnet connections, listening on TCP port 23, but allowing some other connections. So, you would like to use another port for telnet. In this case, you might set like action, redirect source, net destination, 23 protocol, TCP destination port, 29. This redirects the traffic of TCP port 29 to TCP port 23, illustration 49, redirect traffic to a different port. Illustration 50, redirect rule in display list and it takes effect after restarting border engine. Although the network packets can be redirected from one TCP port to another, the network protocol in higher air might be broken by this action. For example, if you use HTTP to access an HTML page from non-standard port, the result might fail to display on your browser completely because the HTML might contain some hard-coded local URL so that they cannot be displayed completely while using the other ports.